Alright, so we're going to go over the quiz review for section 11.1. So in number 1, you're given the points P with coordinates negative 3, 5, and Q with coordinates 2, 1, and we want to find the component form of the vectors PQ and QP. So remember that what you're doing is you're subtracting the terminal coordinates minus the initial coordinates. So for PQ, you would subtract in the order 2 minus negative 3 and 1 minus 5, which is going to give us 5 and negative 4. And for part B, where we want the vector QP, it's exactly the opposite. And in fact, we don't really have to do any work, we just need to switch the signs. In part 2, we're given the vectors u equals 3, 8, and v equals 5, negative 2. So we need to find 3 times u, so we just multiply the components by 3. And here we want u plus v, so we add the x components and we add the y components. When we add the x components, we're going to get 8. And when we add the y components, we get negative 6, I think. And I see a mistake. That should 8 plus a negative 2 is actually plus 6. And wait a minute, that's also wrong. 3 times 3 is 9. Sorry about that. Okay, so now we need u minus v, so we subtract the components here minus the corresponding components over here. So 3 minus 5 is negative 2, and 8 minus a negative 2, I believe, is 10. Now we need 5 times u. 5 times u would be 15, 40, minus 2 times v, that would be 10, negative 4, and so we subtract the corresponding components, and we're going to get 5 and negative 44, I believe. I'm sorry, positive 44. Now we need the magnitude of u, and so that's going to be the square root of 3 squared plus 8 squared is the square root of 9 plus 64 is the square root of 73. Now we need a unit vector in the same direction as v. So we need the magnitude of v, and that'll be the square root of 5 squared, that's 25, and then negative 2 squared would be 4, so that's the square root of 29. And so the unit vector that we want would be what we get when we divide v by root 29. So the vector we want has components 5 over root 29 and negative 2 over root 29. Now we're asked for a vector with the same magnitude as u. I think I used the word length in the statement of the problem, but I often say length instead of magnitude. Length is a bit more informal, and anyway, I was asking for a vector with the same magnitude as u and the same direction as v. So let me give you a graphical explanation of what it is that I'm asking for. So let's say that the vector u looks like this. I know in reality it's not a vertical vector, but in general this is what we're doing. So you've got this vector u, you've got this vector v. What we want is a vector that has the same magnitude as this vector, the same length, but the same direction as v. Well, if this vector we're coming up with has the same direction as v, it's parallel to v. So we're looking for a vector parallel to v that has the same magnitude as this. So now, two vectors are parallel if one is a scalar multiple of the other. So basically what we're doing is we're trying to come up with a vector that looks, well, kind of like that. The same direction as v, but the same magnitude as u. So what we need to do is scale v down or up, depending on the situation, what the numbers are. But we need to correct the length, the magnitude of v, so that it matches that of u. Alright, so how do we do that? Well, what I would do is I would start with this unit vector that we found for v. This is a vector that has the same direction as v, but it has magnitude 1 or length 1, however you want to think of it. But we need it to have a magnitude of square root 73. So what we need to do is we need to multiply this unit vector by the square root of 73. And then the magnitude of the resulting vector will be 1 times root 73, or root 73. So you work with this unit vector because it's a lot easier to work with the number 1 than it is the number square root of 29. So we can, once we know that this has a magnitude of 1, we can scale it up or scale it down with no difficulty at all. Alright, so I think I'm actually going to write it this way. Root 73 over root 29 times 5 negative 2, because I just didn't want to, that involves a little bit less writing than if I put a root 73 here and a root 73 there. Alright, in number 3 we're asked to find the component form of a vector that has magnitude 5 and makes an angle of 2 radians with the positive x-axis. You might remember that at the very end of the notes for section 11.1 we did an example very much like this. So the formula is the magnitude times a vector where the x component is the cosine of theta and the y component is the sine of theta. So in this case what we'll have is 5 times cosine of 2 times sine of 2. And if you want a decimal approximation, make sure your calculator is in radian mode. And then finally we're supposed to come up with a vector component, well, a component form for the vector v, where you've got this arrangement of vectors. You've got w here and u here. So here's what I noticed. Look what's going on here. You've got this head to toe pattern here, or arrangement here. You've got the initial vertex, the terminal vertex, and you've got the initial vertex and the terminal vertex. U plus v is equal to w. So v is equal to w minus u, which means that v is equal to, let's see, that'd be 3, 5 minus 6, 2. So I think that's going to be negative 3 comma positive 3.